Florian, this is Tib. Over.
Tib, this is Florian. Go ahead.
Florian, this is Tib. Assistance required for Mike, Alpha, Tango, Romeo, India, X-Ray. Over.
Tib, this is Florian. Confirming assistance required for Matrix Live. On my way. Over.
Florian is the engineering manager on everything VoIP at Element with a very strong background in the field, and he's here to talk about the second beta of Element Call. We have seen a demo with the fun walkie-talkie mode. This is just one of the few features of Element Call Beta 2. Element Call is also about bringing native encrypted group calls to Matrix. It wasn't enabled by default until now. Can you tell us why and what changed that allows us to turn it on?
Hi, Tib. Of course, I'm happy to answer that question. So first of all, what is end-to-end that content? When it comes to video conferencing, you have the WebRTC stack on the one hand side, and you can connect everything here to establish an end-to-end peer-to-peer call. This is by default encrypted, but what is not encrypted is the signaling layer, and the signaling layer is carried out by Matrix. And there's a really easy reason why we didn't enable end-to-end encryption by default. It's just that it gives us the opportunity to have proper debugging information. Since it's turned out that it's pretty stable all the time, we now decided it's a good point in time to enable end-to-end encryption. That's it.
Okay, so very simply, calls were already encrypted and it was just the signaling part, so sort of the metadata, if we can say.
Yes, yes.
The way to connect the two peers together. That was not encrypted. Does it change anything in the user experience? Do I need to turn a knob or to push a button to get the encryption now?
No, it should be transparent for you. You wouldn't notice. In the meantime, when you had a browser tab loaded with the old version and tried to connect that to a new version, there was some trouble, but I expect that to be only a very few cases. So don't worry, just use it. And if something breaks, give us feedback.
Excellent. There is another feature that I heard about, which is spatial audio. Can you tell me what it is and how it works?
Yeah, yes, of course, I'm happy to. First of all, spatial audio is a buzzword, so let's use this term and go through it. So what is spatial audio in our context? First of all, it is rendering a mono audio source out of your head, and that enables us to place participants in front of you on a Cartesian spatial grid. Sounds complicated. User experience is as follows. It really helps to support the immersion. So when we would stand in a room, both have a conversation, let's say 1 meter between, it's quite natural that your sound is coming from front of me, and if I'm now, as we are currently in a conference, the sound is more or less in your head, because the mono audio is rendered loudspeaker just playback. And the first step forward to enable immersion is really activate spatial audio and render the audio source in front of you. And then on top of that, of course, you have all degrees of freedom to place people on other positions. And this is really a nice user experience. So if we are not two, if we are, let's say, 3 or 5 people in a room, it really helps because then you have spatial information, which helps you also distinguish who's speaking. And also, if you have some noise sources in the background, your brain can carry out the noise reduction for free. So that is really helpful.
Really nice. And I love to play silly games with all the software I do have. So if I move a tile around, is the audio going to follow the tile as I move it? Oh, this is fantastic.
Yes.
I think that's the very best feature of Element Call. Definitely the very best.
we played a lot of hours with that, and it's really fun.
I can imagine. One thing I do have in mind, though, is Elements Call. So it all comes down from MSC3401, I believe, if it's correct. So right. The whole point of MSC3401 was to bring native end-to-end encrypted group calls to Matrix. And Element is trying to be a complete Matrix client. Yet Element Call is a standalone client for now. So is the goal to get matrix call in regular element 2 eventually? And if yes, are you going to re-implement everything in element in addition to element call?
You're asking the right question. And I think I need to zoom out a little bit to answer this question. So first of all, you're totally right. So next gen audio MC3401 is more or less a generalization of what we have for native one-on-one calls, but also covering group calls. That in the long term should replace one-on-one calls plus Jitsi, the Jitsi widget for our conference call. So that's the background and the aim. And on top of that, there's everything in Matrix-led. It is decentralized and scaling with the number of home servers, or in that case, the number of SFUs as a teaser for the end of that call. So yeah, currently we have element call as a separate matrix client, as a proof of concept for the next gen audio project. And it is, as you stated, just a matrix client. So the nice thing about matrix, it's a protocol stack, and from that you can build a lot of different things. The most obvious is, of course, the chat we have currently in place, but element call is just another client for video conferencing. So now the question is, what is the integration path from element call into our mainline apps, which are element web, the iOS app, and the Android app? And yes, so in a perfect engineering world, you would try to craft everything yourself and integrate a nice stack in each of those, video conferencing stack in each of those applications. But in the real world, we have to find a good compromise between timing and features. And there is another interesting thing. So nowadays, modern web browsers offer everything you need to create a nice video conferencing app. So we have the web audio API, which covers device handling of audio devices, video cameras, and so on and so forth. Automatic gain control, echo cancellation, and maybe also speech enhancement like noise reduction, whatever. And the WebRTC stack, which is also part of the web browser, is then for the network part, the network equalization, and so on and so forth. So that the idea popped up in our mind that we just use a web view, so a web browser under the hood, and implement element call on top of that, and then integrating it using a web view in each of our clients is the idea to save a lot of time. While doing that, and you also mentioned it, it turned out that with Jitsi we have a similar concept. We have introduced the widget concept and it can embed external sources in that. And now the idea is to generalize the widget concept furthermore, that you can stack another matrix client on top. Internally, we call that matroskaing matrix clients. And yeah, that's on the way. I think the heavy lifting in terms of discussion is carried out. The next thing is then really to implement it. And the first client, which will be matrosked into our mainline apps, is of course then element call, but you can also think of others like the whiteboard or whatever. So that is also, it's helping also in the field of bio chat. Yeah, and that's, let's say, that's the story around that. So long answer for a short question.
No, that's perfect. I can definitely understand the appeal of going with a standalone client because it's easier to hack around without having to break things and walk around what's already existing in a more complex client. And I also completely understand that there could be a purist approach of re-implementing everything in the clients, but there is little benefit of doing it over embedding parts of element call in the clients. One question I do have in mind is, you say we have started to do the work, so it looks like it's not just super straightforward, because for me, you're just going to use widget to use element call inside element. So it should be like, what, half a day of work? No more?
Yeah. You're asking the right question again. So the widget API currently has a subset of a protocol. You can interfere between the widget and the main app. And with the matroskaing, a concept we really want to expand, that the matrix client on top of the widget could be a full-fledged matrix client. But all the heavy lifting with the end-to-end encryption and so on is then handled by the underlying client. And there we need the proper design, and that's the reason why there was some discussion around, and it's settling. So it's not just to embed element call, it's really that you can embed every matrix client which is using web technologies.
So I guess if you were just embedding element call inside regular element, you would need to authenticate inside element and inside the widget as well. And what you are trying to work on is to make the integration seamless.
Yeah, right. Yeah, right. So the whole trusty thing is carried out by the underlying matrix. Then you can just use the nice properties of the matrix protocol from the perspective of the stacked client. Yeah.
Okay, wonderful. It looks like many other widgets and applications could benefit from that work. So I'm pretty excited to see it in the wild. But there is another thing I'm excited about. I heard about Sean Dubois' proof of concept SFU. So first of all, thank you, Sean. This is a massive contribution to the Matrix ecosystem. You should see Matthew and the VoIP team right now. They're really excited about this work. Florian, can you remind us what a SFU is and why we need one? How is it relevant to element call?
Yeah, of course. So nowadays, SFU is also a big buzzword, and it stands for Selective Forwarding Unit, and it's a major piece in modern conferencing video stacks. Or video conferencing stacks. So a little bit zooming out. So currently, our element call implementation is not using an SFU. It's creating a full mesh. So if you have, let's say, 3 or 5 people in a conference, your upstream of audio and video has to be sent not only to one of those participants, but to all. That doesn't scale very well, especially if you're in Germany and have not so good mobile network, and you're using your mobile and want to have a conference, and it's really limited. And the SFU helps here because every participant has just to send and upload his audio and video streams to the SFU. And then the SFU, as the name more or less indicates, redistributes the streams to the other participants. That is one part of the equation. The other part, which is really important, it also helps a lot in terms of reliability. When I try to establish a peer-to-peer connection to you, like Skype did in the very early days of the video conferencing area, you need some tricks to go through firewalls, and then you have network address translation challenges you have to master. And to help with that, there are concepts like turn servers and so on, but that's not really nice. So it's more straightforward to have an SFU in the internet with a public IP address, and you can just connect. So that is also a big benefit. So let's say the idea. And what you can also do with an SFU, you can stack it. So assume you have, let's say, a big video conference. You have participants from, let's say, France or European. So then you have an SFU placed in the European land, and maybe you have other participants in US, then you have another SFU in the US. You can then have more or less local connections to the SFU and have a good high quality interconnect between the different SFUs. So that also helps then in terms of reliability and quality. And the very nice concept of the next gen VoIP proposal, so the MC3401, is that it is very flexible in terms of the call setup. So if in the room you want to carry out the conference call, no SFU is attached, okay, that's fine. Then you go with a full mesh. But if there is an SFU, you can use it. And then you have the stability, and you can also have large conferences. And it's scaling, and it's decentralized. So that is really, really nice property. And Sean, the inventor of the Pion stack, which is a very important stack for WebRTC written in Go. Yeah, he really contributed a very nice skeleton of an SFU to us, and we had a look at it. It's really nice. Also, are very close, very close, TM, to connect also element call clients to it and to interconnect it with other element call clients. Yeah, but that is, let's say, on a proof of concept level right now. And since the VoIP team is at the current point in time rather small, we have to prioritize. So our first plan is really to get element call into element web, and let's see if we have enough bandwidth on the site to also develop and craft the SFU. But it's really, so if the SFU is in place, then we really have a very nice stack and very reliable stack. Yeah, to have video conferencing really first class in the matrix.
All right, so to summarize a little with my own naive words, a SFU is a sort of relay node on the server side. I'm going to send my video stream and audio stream to the SFU, and then it's going to broadcast it to everybody in the conference. So I don't have to broadcast it to everybody in the conference from my own computer. So it's a way for me to save bandwidth, because usually SFUs would be in data centers and have more bandwidth available than I do have at home. And you said that the SFU still needs a little bit of work before it can go to production and scale element call beyond 8 participants. Is there a lot left to do, or is this something that could be done fairly quickly once element call has been embedded in regular element?
Yes and no. So there might be a shortcut. So when we developed element call, we focused more or less totally on the full mesh implementation, although the MSC also has the SFU bits and and now we have to refactor a little bit the code such that we really also have good modeling of SFU. So the difference is a little bit the following in terms of peers. In the full mesh, you have n peers, n-1 peers, if because you're not peering with yourself. So that's the model here. And with an SFU, you just have the SFU as peer, and you're getting from the SFU a lot of different streams. And yeah, but that's just work to do, not a big thing. It's more on priorities within the team. What's next? I have a strong bias to the SFU, but yeah, you know, the work has to be done. But there's maybe something else worth mentioning when it comes to end encryption. Maybe you remember earlier I stated that with the full mesh, we have transport layer security for the media using the WebRTC. And with and we just have to enable the end-to-end encryption for the matrix portion. With an SFU, that's a different story, because if you terminate your call with an SFU, which then redistributes, then the transport layer security is terminated on the SFU. And here we have to also work further, and the buzzword here is insertable streams. So we need to encode our audio ourselves within the web browser and then plug it as insertable stream into the WebRTC, such that is then really end-to-end encrypted. So that is also work we have to carry out. And as we are the privacy preserving company, we really want to have that in place when we go live with this. And this is also a big portion of the bucket we have to carry out in the SFU world.
All right. That was very enlightening talk, and you provided very clear answers to everything element call and MSC 3401. Do you have any final thoughts to conclude the episode?
So it's really a fast evolving area. It's really nice, and yeah, I'm really looking forward to get all this carried out. In the meantime, we have an open position in the VoIP team, and if you're interested speeding up a little bit, I'm more than happy if you apply.
Excellent. Thank you very much, Florian, and thank you very much, Matrix Live, for following us for this episode. I leave a link in the description to the job description, to the MSc 3401 if you want to have a look, and to the beta of Element Call, of course. And I'll see you next week. See you around.
Bye. Thanks for having me.